Hello everyone. Good evening, all of you. Hi everyone. Good evening, all of you. Everyone, please join the session and let me know your name in the chat box. Once everyone join, please tell me. Hi everyone. Okay, yes. So guys, I was discussing the dynamics, right? I was discussing the dynamics analysis of single slider crank mechanism. So in that dynamics, I was discussing the I have discussed the radial thrust force. Now I am going to discuss the uh, radial torque, right? The tangential force to the crankshaft. Okay. So can anyone tell me the expression of this? Can anyone tell me the expression of this, my dear? Can anyone share? No reply. Okay. So guys, now I am going to discuss. Okay. How many students are watching? Can you tell me, please? See everyone. Great. Now see, my dear. Turning moment we have to find out. Okay. See. See, my dear. The tangential force acting on the crank or crankshaft. See, tangential force acting on the crank, right? So the tangential force will be your Ft. Ft, how can we find out? See, Ft is your the component of this Fc, and the angle is theta plus beta. So then this will be your Fc sine theta plus beta. Correct? Fc sine theta plus beta. I hope this is clear. This is your Fc sine theta plus beta. So here Fc is your what? Fc we have already calculated. It is your combustion force F upon cos beta. F upon cos beta. So you can write F upon cos beta. Beta. Ft is equals to F sine theta plus beta divided by cos beta. Clear? So remember that, my dear. Okay, everyone. This is your tangential force acting on the crank. Now the next part is your turning moment, guys. Fifth. Turning moment on the crankshaft. Turning moment on the crankshaft. That is your torque. So how can we find out torque? Torque is your R cross F. This is your mod R, mod F into sine theta. Sine theta is angle between these two. So here R and F is your tangential force. You can see this is the radius. This angle is your 90 degree. So this is your tangent, right? And this is your radius R. Angle is 90 degree. Therefore, you can say that sine 90. So therefore, torque is equals to R into Ft. Right. So therefore, thrust force that we are getting F into sine theta plus beta divided by cos beta into R. Right. So F into sine theta plus beta, sine theta plus beta, cos beta into R. Okay. So this is very, very important expression of the turning moment. Clear, everyone? And 3 times problem is asked, 3 times question is asked in GATE. Problems asked in GATE. Right. So remember that, everyone, please. Please note down these discussions, today's discussion, please, everyone. Have a look and note down. And once done, let me know. Note down, everyone. Done, everyone? Can we see the problems now? Now, guys, I am going to give you some problems based on these discussions. I hope you all have noted this down. See, find out, guys, the answer for this. Everyone, please find out this one. Find out the answer for this problem. Turning moment, you need to find out. Everything is given. I have already discussed how to find out the turning moment. Can anyone tell me the right answer for this? Can anyone solve this? Hello. Where are the other students? Yesterday, Koki, Isha, Srivastav, all of you, Parthamesh, and the other students, Aditya, Rahul. Where you been, guys? Please find out the answer of this problem. See, I am going to solve everyone. How can we solve this quite easy problem? Quite easy problem it was. See. See here again, this is your F. This is your F, that is the F force which we put here. This is your F, right? So you can see the force which is applied on the piston. The force which is applied on the piston, that is called your F. Okay. So now see. Okay, my dear, now see. So here what we can say that 5 kilonewton force is asked. So that is quite simple. So here, this is the crank. Therefore, this angle is your theta. This angle is your beta, my dear. So you can just write this angle is going to be your beta, right? And this is your theta. Theta is your 90 degree, because theta is the angle between this line and crank. Now, what we can do here, we have to find out the turning moment, right? Turning moment formula we know. We have already derived the turning moment formula. It is your F into, you can see now, is the formula F sine theta plus beta upon cos beta. Into R, right? F is your 5 sine theta plus beta. Now we have to find out the beta. How can we find out beta? By using the trigonometry. In this triangle, you can write sine beta is equals to 200 by 800, correct? You can see this is your 200 is your 800. This is your 1 by 4. Sine beta is equals to 0.25. Beta is, my dear, tan inverse 0.25. So tan inverse 0.25, what we are getting? We are getting 14.47, right? 14.47. So you can write here 90 plus 14.47 divided by cos beta 14.47 into R. R is your 200 mm means 0.2 meter. So in that case, you are going to get a turning moment. 1 minute, let me find out this. Sine 90 plus 14 means 104.47 upon cos 14.47. So this we are getting, everyone calculate this. This we are getting approximately 0.998, right? 0.998. Since the force is given in kilonewton, therefore we are going to get it in kilonewton meter. So it is your 1 kilonewton meter, right? 1 kilonewton meter. Now, my dear, see everyone, next discussion, next problem which I am going to give you. So I hope this part is done, everyone. Next part of discussion is, see. See my dear? Do this, my dear, please. A slider crank mechanism is shown in this figure. At some instant, the crank angle is 45 degrees. The crank angle is 45 degrees. And a force of 40 Newton is acting toward the left of the slider. The length of the crank is 30. Length of the crank is your 30. And the connecting rod is 70. This is your 30, this is 70. Ignoring the effect, the magnitude of the crank shaft torque needed to keep the mechanism in equilibrium. Can anyone find out? I'm giving you time to find it out. Please find out. Please find out and tell me the torque. Find out, guys. Find out, everyone, please. Anyone?
Recording in progress.
Shall I start? Shall I start, everyone? Please allow me to start. Okay, guys, we were discussing this problem. See, we were discussing this problem, everyone. What I can say you, see, a slider crank mechanism, this is the 45 degree. This is your 30. This is your 70, right? I hope this is correct. Now we need to find out this angle, beta. Without beta, we cannot solve this. So how can we find out beta? So we know the relation. The relation is your, first you find out n. N is your L by R. 70 by 30 means 7 by 3, right? This is your 7 by 3 means 2.33. Now what we can say, we know the result n sine beta is equals to sine theta. N sine beta is equals to sine theta. So n we know 2.33 sine beta is equals to sine 45. Sine 45 1 by root 2. So from here we can find out sine beta. We can find out directly beta. 1 by root 2. Tell me what is beta, everyone. Beta we are getting 17.64 degree. Correct. Now we know very well the torque. We have to find out what? We have to find out the torque in Newton meter. The magnitude of the crankshaft torque in Newton meter. So you can see the torque is equals to, formula is your F into sine theta plus beta divided by cos beta. I have already derived this into R. So torque is equals to, force is 40, sine theta is your 45 degree, 64 divided by cos beta. Beta is your what, my dear? Beta is your 17.64 and radius is your 0.3, right? Because it is 30 mm, right? So sorry, 0.03. 30 mm, this is your crank radius. So 30 into -3. Torque is what, my dear? Please find out. Everyone is saying the right answer. Absolutely right. 1.12 Newton meter. 1.12 Newton meter is that is the right answer. Okay. Absolutely right. Correct. This problem is done. So guys, now I am going to start another topic that is also very, very important. Okay. That is very, very important. And I am going to start this topic. That is your, see, this is your flywheel. Flywheel is also very important topic. So let's start, everyone, doing this question, flywheel. Flywheel topic that I'm going to start, everyone. Tell me whether you want to first study the flywheel or gear. Whatever you are comfortable, I'm going to start that. Tell me. Flywheel you want to start or gear? Tell me, everyone, which one? Which one you want to study first? Class is going on, loading rather, buffering. For me it's buffering. No, there is no buffering. I'm the network is clear, internet connectivity is good. I don't think you are getting any buffering. Just share your opinion, which topic you want to study first, gear or flywheel? Tell me, guys. I didn't receive any reply, guys. I have not received any reply. Please share the chat of the students. Okay, now I'm going to start. It's my will. I'm going to start. I'm going to start the flywheel topic. Okay. Because no one is responding. Someone is saying gear start, sir. Flywheel coach. Flywheel is a small topic, so let me start the flywheel topic. It will be completed in next 2 hour sessions. Okay, see, flywheel topic I'm going to start. See, flywheel. So actually, what is the purpose of flywheel, my dear? It is a reservoir which store energy, right? It is a reservoir which store energy, and it supply energy whenever required. And whenever you are getting more energy, it stores energy. So it is a reservoir of energy, that you can say. Just like in casting, there is a one term riser. Riser is what? It is a reservoir of molten metal, and it supply molten metal to the casting whenever shrinkage occurs. Similarly, flywheel is what? A flywheel is used in machines, serves as a reservoir which stores energy during the period when the supply of energy is more than the requirement. When the requirement is less, then it stores the energy, and whenever the requirement is more, then it supplies the energy. So that is actually a flywheel. So start writing the definition. Start writing the definitions. Shall I continue? Hello. Shall I continue, or any problem? Okay. See, a flywheel used in machines serve as a reservoir. Serve as a reservoir which store energy during which store energy during during the period when supply of energy is more than the requirement. More than the requirement. And release it during the period when the requirement of energy is more than the supply. More than the supply. Flywheel. Right, that is very important line. So therefore, sometimes it stores energy, sometimes it discharge energy. Therefore, in that case, it does not maintain a constant speed. It simply actually having there's a fluctuation of speed. So there you can also write some points. Flywheel does not maintain a constant speed. Right. Okay. And it also simply reduces the fluctuation of speed. It simply reduces the fluctuation of speed. You can write it simply reduces the fluctuation of speed. It simply reduces the fluctuation of speed. See, because whenever there will be less energy, the speed will reduce. Then what fly will actually do? It supplies the energy because there will be more requirement. So it's actually supports, it actually minimizes, reduces the fluctuation of the speed. Okay. Now, next important, it does not control the speed variations caused by the varying load. So that is actually the use of governor. It does not control the speed variations caused by the varying load. Right? It does not control the speed variations caused by the varying load. Now, fluctuation of speed, you can see, first note down everyone. Actually, this is the governor part, right? Due to the variation of load, there will be the fluctuation in speed. So now we need to understand the fluctuation of speed. So the difference between the maximum and the minimum speed during a cycle is called maximum fluctuation of speed. So whenever more energy is there will be more speed. Maximum speed, less energy, less speed, right? So guys, the maximum fluctuation of speed will be n max minus n minimum. Okay. So guys, you note down first. Then I can tell you fluctuation of speed. See, fluctuation of speed. Fluctuation of speed. fluctuation speed. Fluctuation of speed is C. The difference between the maximum and minimum speed during a cycle is called maximum fluctuation of speed. Here you can write, my dear, n max is equals to maximum speed, n minimum is equals to minimum speed, right? So therefore we can write the maximum fluctuation of speed is equals to n max minus n minimum. Mean speed is equals to n max plus n minimum by 2, right? This is very important, everyone. Note down this part. I'm giving you time. Note down, please. जूस चम्मच प्याले ठीक है ठीक है once done please let me know everyone Done. Great. Now see everyone. Next important is your coefficient of fluctuation of speed. See. So actually mean speed, we are assuming the mean speed as capital N. Remember that. Capital N we are assuming as a mean speed. Next, my dear. This is very important term, coefficient of fluctuation of speed. Of speed. CS, right? It is the ratio of maximum fluctuation of speed to the mean speed. Right? Means CS is nothing. N max minus N minimum divided by mean speed. Mean is your N max plus N minimum by 2. Right? So here we can write it is going to be your N max minus N minimum divided by N. Correct? Now CS is equals to see if you convert RPM into omega, sometimes omega is given. You can write omega max minus omega minimum. Again, the same problem started. Omega max minus omega minimum divided by omega max plus omega minimum divided by 2. Right? This is your omega max minus omega minimum divided by omega. For example, suppose CS is your 3%. So in numerical, you can use it as a 0.03. And if it is given CS is your plus minus 3%. Then in numerical, you have to use 0.06. Right, remember. Plus minus means you have to consider all the magnitudes, right? So 3 in plus side, 3 in minus side. So therefore, total fluctuation is 0.06. So remember that. This is the coefficient of fluctuation of speed. Note down, guys. Clear, everyone? See, my dear. Next discussion is coefficient of steadiness. It is denoted as M. It is actually the reciprocal of, it is the reciprocal of coefficient of fluctuation of speed. Right. So it is we denoted as M is equals to 1 by CS N upon N max minus N minimum. Correct, my dear? N upon N max minus N minimum. N is your mean, right? N is your mean. Maximum fluctuation of energy. Okay. Maximum fluctuation of energy. That is important topic. Okay, that I am going to discuss. Very, very important topic that is. So I'm going to finish it today and problems on tomorrow. So let's take a break of 5 minutes. Then I'm going to start this, right? Maximum fluctuation of energy, right? This is the topic. Let's start, everyone. Welcome back, everyone. See, guys, the maximum fluctuation of energy. This expression that we are going to discuss. So, guys, I am going to draw the turning moment diagram because we know the area of the turning moment diagram torque into theta, right? So that is going to give us what? Energy. So here, everyone see the turning moment diagram for a multi-cylinder engine. The turning moment diagram for multi-cylinder engine as shown in figure. See, everyone, suppose this is the turning moment diagram. See, suppose this is the diagram. Right, now see. So here this is a turning moment diagram. This is your diagram. See, suppose this point is your A, this point is your B, this point is your C, this point is your D, this point is your E, F, this point is your G, right? Now, this is your turning moment, T. That is the turning moment T, and crank angle. Crank angle is theta, right? So here, suppose this is the above area. This area is suppose A1. This area is suppose A1, right? A2, this area is your A3, this area is your A4, right? This area is your A5, this area is your A6. Okay. Now what I am going to tell you, this derivation is also asked in your semester exam. Okay. Let A1, comma A2, let A1, comma A3 A3, comma A5 be the area above the mean torque line. Be the area above the above the mean torque line. This is the mean torque line. These are the area A1, A3, A5. Right. And A2, A4, A6 be the area below the mean torque line. Right, below the mean torque line. Correct, my dear? So here, you know very well that the area of the torque versus torque versus theta diagram will give you the energy, because theta having no unit, torque having unit Newton meter, it will become joule, right? So note down this part. Then I'm going to write the energy. Let's support the energy in the flywheel at point A is E. E energy is stored in the flywheel at point E. And now the energy at point B in the flywheel, because flywheel moves with a turning moment. So this area, right, is the positive energy is stored in the flywheel. Therefore, at point B in the flywheel, the energy is E plus A1. A1 energy is added here. Now at point C, this energy is loses. Suppose here the requirement is less, right, and supply is more. So whatever supply that is stored in the flywheel in that case, but here your demand is high and supply is less, then flywheel actually supply energy to the right machines. Therefore, energy decreases. So this is how it happens. See everyone, suppose let the energy in the flywheel at A is E, and the energy in the flywheel at point B energy flywheel at point B, right? What is going to be happen at point B? That is E energy at point A. It will be E plus A1. A1 energy will be there. Similarly, the energy in the flywheel at point C. So C will be what? The energy at B minus A2. So here it will be your E plus A1 minus A2. Now at point D, A3 is going to be add. Now the energy in the flywheel at point E. At point E is your A4 is going to be decrease, right? A4 is going to be subtract minus A4. Now the energy in the flywheel at point EF. तो F point पे क्या होगा? Minus A4, now plus A5, and then again G पे minus A6 plus A5. Correct, my dear? Energy in the flywheel right, minus A6. Correct. I have written all the energy, everyone. Please write this, all this part, everyone write. Very important. Key, that is the energy stored at all the points A, B, C, D, E, F, G. Right. This is how. Note down, everyone. Once done, please let me know.
अस्सलाम वालेकुम जी, उम्मीद करता हूँ आप ठीक ठाक होंगे। आज मुझे एक बहुत बड़ा मौका मिला है पाकिस्तान।
Everyone done? Very good, Mukul. Very good. Hello. हाँ बोलिए। हाँ हाँ। Okay, okay. Tell me, Risha. Okay. Right. Right. Okay. Okay. Great. Okay. Yeah. Yeah. Right. Actually, I am currently taking class. I just received your call. Can I call you after 7 p.m. if you don't mind? Okay. Okay. Bye. Okay, guys. This we are getting everyone. See. So next, my dear. Next, guys, when I'm going to write here, maximum fluctuation of energy. So, guys, see. Here you can see you are going to get maximum energy where? See. At some point you are going to get the maximum energy, and at some point you are going to get the minimum energy. I will show you one problems in that. It will be more clear for you for the understanding, right? So here, guys, see, 1 minute. There will be fluctuation. Suppose this is the area. If when value will be there, it will be more easy for you to understand. Suppose some value will be given. So maybe at point E you are going to get the maximum energy, E max, right? At point maybe F, at point maybe C you are going to get the minimum energy. So this is how you have to write the energy at all the points, and you must find out the value, right? You must find out the value at all the points. Find out the value at all the points. Here it will be A6. Okay. And wherever you find the minimum value, suppose at F you are getting minimum, at B you are getting maximum, then just do the subtraction of these two, you are going to get the maximum fluctuation of energy. Okay. So now what I am going to actually tell you, right here, maximum fluctuation of energy. Maximum fluctuation of energy. This we denoted as a delta E. It is equals to maximum energy minus minimum energy, right? So if suppose a graphical method is there, this graph is given to you in all the problems, then you can do this method to find out E max or E minimum. This method, right? And whenever graph is not there, in that case, what you can use? In that case, here you can write the maximum energy at EB and the minimum energy at EF. So whatever will be there, you can use that and proceed. But here, whenever it is not given, in that case, you can do delta E, that is the fluctuation of energy, is your E max minus E minimum, right? So here, my dear, we can proceed like energy in a rotating body. Flywheel is a rotatory body. It is your I omega square. It will be I is the moment of inertia, omega maximum square. Then it will be maximum energy minus half I omega minimum square, right? So here you can write delta E is equals to, my dear, half I omega square omega minimum square, right? Now what we can write, delta E is equals to half I. This you can write A square minus B square. This is going to be your omega max plus omega minimum, omega max minus omega minimum, right? So this we can write, my dear, like this. See, this we can write delta E is equals to omega max plus omega minimum divided by 2. This is your omega max minus omega minimum, right? So here what we can do, my dear, we are going to do one thing. See, I'm just going to do some mathematics here. See, my dear, I'm going to use this omega max plus omega minimum divided by 2 divided by same thing like this. Same mathematics, right? I'm multiplying the mean in numerator as well as denominator. Now you can see this is the mean. Okay, so here you can write like this, that you know very well that sir, omega mean, we denote omega mean as omega. It is your omega max. It is your omega max plus omega minimum divided by 2. Omega max plus omega minimum divided by 2, right? So here what we can say, my dear. And one more thing, you know that CS is your coefficient of fluctuation of speed, omega max minus omega minimum divided by omega max plus minimum divided by 2, right? This we know very well, right? See, omega max plus omega minimum by 2. CS I have discussed, right? This is the CS. Omega max minus omega minimum upon omega max plus omega minimum by 2. Now see everyone. So in that case, now this you can write, see, this is omega, right? Omega mean. Always remember this is omega mean. So you can write I into omega square and into this term, see, this upon this is nothing but CS. This is your CS. So the formula is derived, that is called your delta E, the coefficient of fluctuation of energy in a flywheel, that is your I omega square CS. Very, very important formula. Hope you guys have already remembered this result, right? So please note down this mathematics, everyone. Note down this mathematics, everyone. Very important. Note down this mathematics, guys. Note down, everyone. I hope everyone has noted this down. See, now guys, when we proceed in this expression, the most important thing is, remember that, where omega is the mean angular velocity. Remember that, mean angular velocity. And CS is your coefficient of fluctuation of fluctuation of speed of the flywheel. Clear everyone? I is the moment of inertia. Moment of inertia, right? Now, moment of inertia sometimes we calculate by using I is equals to mk square. Mass into radius of gyration square. So here in this expression, my dear, m is equals to mass of the flywheel and k is your radius of gyration. Right. Always remember, ring, if you have a ring type flywheel, my dear, or if you have a disc type flywheel, so for ring type flywheel, mr square, and here mr square by 2. Disk type. So here radius of gyration is your k is equals to r, and here k is equals to your r by root 2. K is equals to r by root 2, correct? So that is very, very important. Remember that. This is very, very important. Okay. So guys, now I am going to tell you some problems on this, so that you can understand how to solve the problems. See the first problem. Note down this part. Delta E I omega square CS. This is the one formula, and that is very, very important formula. See the first problem, my dear, which we have. Sometimes radius of gyration is directly given. A flywheel of mass 3 kg has a radius of gyration (1.6 meter). Find the energy stored in flywheel when speed increases from 2340 RPM. Can anyone solve? Find the energy stored in. So whatever fluctuation delta E you have to find out. That is the energy stored in the flywheel. You can write. If some students, what is this delta E? That is the energy stored. Energy stored in a flywheel. Right. Find out, guys. How can we solve this? Here in this, you can see N minimum is given to you. N maximum is your 340. So CS is required. First calculate CS, then I omega square. Find out. I am not going to solve this. Please find out. Find out, my dear. Find out. Everyone, please. Can anyone tell me the right answer? Because very simple formula is there. You have to use that formula to get the answer. Delta E. Still not getting the right answer. See everyone, no one is responding, so I am going to solve it. See, quite easy. First, we are going to find out the CS, fluctuation of speed. It is your N max divided by N max divided by 2. 340 minus 315. This we are getting everyone CS. Once you solve this, we are getting 1 minute. Let me calculate in the calculator. Very less 0.00763. Right. Once we got this, now I. So moment of inertia is also required. So I is equals to mk square. Mass is given 3 kg. Radius of gyration is 1.6 square. Right. So it is 3 into 2.56. Right. .68 kg meter square, right? It is your I omega square CS. So omega mean we find we need omega mean, right? So omega mean, how can we get? So here first we need to find out N mean. N mean is your 340 plus 15 divided by 2. N mean is equals to 340 315 divided by 2. Very good, very good. Everyone's answer is right. That's amazing. RPM, right? Now see, Now see what we can do here. So here omega mean is required, right? 2 pi this we are getting, my dear. $34.27. So delta E is equals to 7.68 34.27 CS is your 0.0763. So this we are going to get 0.0763 into 7.68. This we are getting, my dear, 689.50 kilojoule. The right answer? Correct, everyone? This is the right answer, okay? Absolutely right answer it is. Next problem, guys, I am going to give you, see. Absolutely right. Kokisha, Srivastav, all of your answer is right. Very good. I think I'm not getting that question here. Find out, everyone. A flywheel of moment of inertia 9.8 kg per meter fluctuates by 30 rpm for a fluctuation in energy of, so here fluctuation in energy is given, delta E is given to you, right? The mean speed of the rpm means n is asked, right? Mean speed. Can anyone tell me the right answer for this? I'm giving you time, please find out. Find out, all of you, find out. Find out, everyone. Sir, but why in kilojoule? No, it is in joule, joule. It is in joule, not in kilojoule. It is in joule, my dear. See how we can solve this. Quite easy problem. Moment of inertia is given to you. So here what we have given, my dear. I is your 9.8 kg meter square. And fluctuation of energy is your 1936. Right? Joule. No problem. And n mean speed is required. N mean we know very well, that is your maximum speed plus minimum speed divided by 2. Now guys, here one word is written, fluctuates by 30 rpm. So fluctuates by 30 rpm for a fluctuation in energy. So here it is, whenever you are going to write CS, so CS is what? Coefficient of fluctuation of speed. It is n max minus n minimum divided by n, right? It is your 30 by n. 30 by n, right? So this is your 30. That is the fluctuation 30. Correct, my dear? So here what we can write, see, this is also your n. N means n. So here delta E is your I omega square CS. So it is your 1936. I is this, and omega is your 2 pi n by 60 square, and Cx is your 30 by n. Right, my dear? So this you can find out. So here it's quite easy. 1936. I is your 9.8. It is your 4 pi square divided by 60 square. Is your 30 into n. Right. So here, once you solve, you are going to get the answer. Can anyone solve this and tell me the right answer, what we are getting? So we are getting approximately the answer will be. Can anyone solve? Still not getting the right answer? Hello? Good evening. अच्छा. क्लास में 2 मिनट में करते हैं, ठीक है। What we are getting, my dear? What is the right answer? This we are getting, my dear, approximately 600.48 RPM, right? 600 RPM is the right answer. So right answer is your A. Clear, my dear? Very good, very good. Srivastav, but why kilojoule? What kilojoule? What you are writing? I'm not be able to get you, my dear. So thank you for joining me, everyone. Thank you for this session. Bye, everyone. See you tomorrow at the same timing. Bye. Thank you.